Next, we move on to the box plot. So we have seen a dot plot, then we have understood the histogram, and now we will see what is a box and whisker plot. So box and whisker plot is a graphical representation of a dataset summary statistics, which allows you to visualize the distribution. You can talk about the central tendency in terms of the median and the spread of the data in terms of your IQR. And you can also identify the outliers from this box plot. So basically, you will have a box which represents the IQR, that is the middle 50% of the data. Then you will have whiskers. Whiskers are basically the lines extending from the box. Then median is there. Median is inside the box, that is a line that represents the median. And you will also have the outliers if present in the data set. Okay, and that we denote by your asterisk or maybe some dots. So let us see how to draw this. If you consider the same example of the age data set that we had for your histogram, and you want to now draw a box plot for that same data, then first of all, you need to order that data set. You have to arrange it in ascending order. So if you see over here, we have arranged it in the ascending order now. Okay, it's starting from 25 and then it is going up till 60. Now, once you have ordered the data set, the next thing that you have to identify is the median. Median is the middle value of the data set. So in this case, since you can see that there are 30 observations, so median will be the average of the middle two observations. So if you look over here, these two observations over here are the midpoints. So the average again, that is the median, will be 35. So median Q2 is 35. Also, the first quartile, that is Q1. So you can see that Q1 would be 29 in this case. And you can see that the third quartile again will be 43. So based upon this, you can find IQR, which is 14. Now you draw a box. You start with a box which starts from Q1 to Q3, that is 29 to 43. You will draw a box and you will draw a line in between to represent Q2. That is, you will draw a line at 35. And then you will draw the whiskers in order to determine the outliers. So your lower whisker basically is calculated, is a line that is drawn from the box. Okay, so lower whisker will be the line that is drawn from the left end of the box and it goes up till this point. So Q1 minus 1.5 times of IQR. So I will now explain you why this is 1.5. So I will just first complete this box plot example. So Q1 is 29 minus 1.5 times of 14, that is 8. And similarly, upper whisker will extend from the right side of the box and it will go up till this. So you find that if you substitute these values, what you get is 64. Now, this is what is written over here. You draw a line from the box left edge to the data point greater than the lower whisker. And from this side, you will draw it to the data point which is less than the upper whisker. So in this case, you do not have an outlier because your box plot is looking like this. So let us first understand the box and then I will explain you about the whiskers. So you have Q2, this is the median. So you have drawn a line over here. This box starts from Q1, that is 29 to 43. Let us just correct it. Yes, from 29 to 33. So Q1 to Q3. So the box is drawn. Now, as I said, your whiskers will start, the lower whisker will start from this left side. A line is going and it will go up till the data point which is just greater than the lower whisker. Now, the lower whisker value is 8, right? And the data point which is more than that is 25 because there is no other observation between that. So, your whisker will only go up till 25. Similarly, if you look on the right side, you will draw a line starting from here and it will go to the data point which is just above the upper whisker that you have calculated. So upper whisker is 64. So you will go up till the data point which is less than that, which means that you will only go up till 60. So you make a line over here. Now note that you are not drawing these whiskers till your lower whisker point or till 8 or 64. Instead, because these are just the values that you have obtained in order to mark the whiskers over here. It is not the exact data point, and you have to mark the data points in the data set in this box plot. So it will go to the data point that is 25, which is above the lower whisker, and this side it will go to the value which is less than the data point, less than the lower whisker, that is 64, and 60 is the last or the maximum value that you have. Okay, so this is how you draw your box plot, and we will also see this in terms in, so this we will also learn how to draw the box plot using Python. And since in this data set you can also see that there is no outlier, if you would have some observation, suppose whose age was 100, in that case it is beyond your 64, right? 64 is the upper whisker and 100 is much above than that. So you would mark, suppose it is coming here, so you will mark an asterisk over here, which shows that this is an outlier in this data set. So by just looking at the box plot, you can identify what is the median at the center of the data set. Then you can also talk about the spread of the data by just looking at the box. Okay, and you can also identify the outliers from that. Moreover, you can also identify the shape of the distribution. If your box plot is such that this median is equally dividing the box over here, that is, it is equidistant from your Q1 and Q3, it means that you have a symmetric data set. Okay, it will look something like this. Otherwise, if your Q1 is very much stretched out to the left hand side, so Q2 is towards your Q3, right? Then it means that it corresponds to left skewness. Okay, because Q2 is median, this is mode, and here somewhere you will have your mean for left skewed data sets. So by just looking at the box plot, you can also identify the skewness or the asymmetry present in the data set. Likewise, here also it is more spread out towards the right side. So you can also say that this is right skewed. Okay, so now I will explain to you why do we have IQR when we are calculating the lower whisker, why do we have that multiple 1.5 there. So before going ahead, let me just recall a few minor things. See, if you can recall, then if you have a data set like this and your Q1 is to this side and Q3 is here, so we know that Q1 corresponds to lower quartile, that is 25% of the observations are below this. Okay, and if you look at Q3, then 25% are on the right side, but rest 75% corresponds to this side, to the left hand side. Okay, so you will basically have here it is 0.25. How much data points are below this? It is 0.25, and the area below this corresponds to 0.75. Okay, and the rest is above it, that is 0.25 is above it. And if you look at the standard normal table, then this 0.25 actually it corresponds to z value of 0.675, and this corresponds to 0.675. Okay, so if the z value you have to calculate, z score is x minus mu by sigma, right? And when you are standardizing basically, so x, if instead of x you have Q1, because here we are interested in Q1 and Q3, so Q1 would be mu plus sigma times z. Since mu is 0 in this case, so which basically means that it is minus, z is over here 0.675, so it is minus 0.675 sigma, and Q3 is basically mu plus sigma z again, so it is 0.675 because it is to the right side of the mean. So these are the two values that we have, Q1 and Q3. Okay, now recall that when we had that standard rule of thumb, then we said that if this is the mean in between and this is your mu minus sigma, this is mu plus sigma, this is mu plus 2 sigma, and this is mu plus 3 sigma. Likewise, you will have mu plus 2 sigma and mu plus 3 sigma. Minus. Okay. Now, recall that we said we will have 68% of the observations would lie between this point, 68. If we have this data set from here till here, then it will have some 95%. And finally, if we go between from here to here, from mu plus minus 3 sigma to this, it will be 99.7%. We have seen these things. Now, suppose that you take, in this case, we had Q1 lower whisker, basically LW is basically Q1 minus 1.5 times of IQR. Okay, and upper whisker is basically Q3 plus 1.5 times of IQR. Okay, now the question is that why is it 1.5 only? Why not take 1 or 2 or 3, some other number? So let us see why can't we take it. Suppose we take the scale as 1. Suppose we take it as 1. Then in that case, the lower whisker will be Q1 minus 1 time of IQR. This is basically Q1 is what? Q1 we have calculated over here initially that it is minus 0.675 sigma. So you will have minus 0.675 sigma minus IQR is Q3 minus Q1. Q3 0.675 minus of this. So you add up these quantity and you will get 1.35. So this will become plus over here. So you will have 1.35 sigma. Q3 minus of Q1, that will be Q3 plus Q1, and you get this quantity which basically corresponds to minus 2.025 sigma. Okay. Similarly, if you calculate the upper whisker, it will be Q3 plus 1 into IQR, and then in this case again you will have minus. So here you will have plus because Q3 is this. You will have minus times of plus 1.35 sigma. So this is basically 2.025 of sigma. So here if you see, it is going from 2.025 sigma to 2.025 sigma, which basically means it is going from 2 sigma limits. It is just going till this, and within the 2 sigma limits you have only 95% of the observations. And our interest is to capture as much as possible in this case. So if we can talk about 99.7%, approximately this, then it would be better, right? So instead of scale 1, if you opt for scale 2, right, in that case, lower whisker again will be Q1 minus 2 times of IQR. Q1 is minus 0.675 sigma minus twice of your Q3 minus Q1. Okay, so Q3 minus again Q1 will be your 1.35. And if you solve this, this basically comes out to be minus 3.375 sigma. And likewise, if you have the upper whisker, it will be Q3 plus twice of IQR. This comes out as 3.375 sigma. Okay, now again this is going much beyond that. It is not following that 3 sigma limit thing. So now instead of that, if you take scale as 1.5, what you get is that lower whisker in this case basically becomes minus 2.7 sigma and the upper whisker comes out as 2.7 sigma. So you can say that this is giving you a better answer because this is very much near your 3 sigma limits. And in this case, actually the exact value you will get at 1.7. But in order to maintain symmetric behavior, we just consider it as 1.5. So that is why this 1.5 appears when you are calculating your lower whisker and upper whiskers. So these were the 3 visualizing tools for your numerical variable. Now you might have 2 numerical variables and you want to investigate the relationship between them. And in order to do that, we have scatter plots which are used to study the relationship between the 2 numerical variables. Suppose these are the monthly records for your amount that is spent on advertising and sales revenue by different months. Right? These are the values and you want to investigate the relationship between these 2 numerical variables. So what you can do is that you can draw a scatter plot where on the x-axis you will keep your one variable that is advertising and the other one is your sales revenue. And you will mark for corresponding to each observation, you will mark a dot over here. Now by looking at these dots, you can identify and say what is the strength of the relationship. You can talk about the direction of this. So if you see over here, it is positively associated. These 2 variables are positively associated because as you are increasing one observation, the other is also increasing, right? So they are positively associated. Next, if you see that it is a linear relationship between them and the strength obviously is high because if you draw a line over here, these points are close to that line. Right? So the points are strongly related to each other. So by just looking at this scatter plot, you can identify the relationship between the 2 numerical variables. Had it been in the opposite direction, had it been in this way, then you would say that there is a negative relationship between them. In this case, there is a positive association. Now suppose you are given 2 scatter plots. Then by just looking at these scatter plots, sometimes you may not get the correct picture because you may not be able to identify that what is the relation between them or the association. In order to do that, we have one measure which is the correlation coefficient, and it is a statistical measure that quantifies the strength and direction of the linear relationship between 2 quantitative variables, that is the numerical variables. So how do we calculate it? The formula is this. So in the numerator, you have summation xi's minus x bar. So basically xi's are the data points which correspond to advertising spent. These are xi's and the next one is these are the yi's. Over here, this is x, this is y. These based upon this, you can calculate the sample mean. Here you can calculate this sample mean. So xi minus x bar you can get, yi minus y bar you can get. Their squares also can be calculated. So you just have to substitute the values over here. Right? And whatever value you get over here, it is going to tell you the correlation coefficient or the strength or the linear relationship between these 2. And in fact, if you solve this, what you will find is that it comes out very much close to your 1. So it is 0.98 or 94, something like this. So note that this R can vary from -1 to 1 only, right? So if you are getting the value that is 0.98, which is very much close to +1, it means that there is a strong linear relationship between the 2 variables. Okay. However, had it been very much close to 0, you can say that the weaker relationship between these 2. Both on -1 and +1, this is stronger. But on +1, if the correlation coefficient is near +1, it means that they are positively associated. If it is on the negative side, it means they are negatively associated, but still there would be a strong relationship. So if you are getting, in this example, if it is 0.98, it means that there is a strong positive relationship between these two variables. Okay? And it is a unit-free measure of association that we have seen from the formula itself. This was about your two numerical variables. Now, you may come across situations where your numerical variable can be further broken down into different categories. In that case, you can use the side-by-side box plot. Suppose you have the ages of a group of individuals, but that we know that it can be categorized as either male or females, right? So in that case, you can draw two different plots and make comparison between those two categories. So if you want to make a comparison between multiple data sets, then you can use side-by-side box plot for easy visual comparisons. So here you can see that, if you recall, then box plot can talk about the median, it can talk about the shape, okay, and it can also identify the outliers. So if you have side-by-side box plot also, so you can make comparison between different categories as well, between different box plots. For instance, if you have the salaries of two different departments, right, Department A and Department B, okay, and you want to make you want to draw a box plot for this. So basically what is happening over here is, you have in a firm, they will have the salaries of all the employees, right? But now they might think that these two departments salaries can vary, so these are the two categories based upon which they divide the data set. So one category contains first department, that is Department A salaries, and the other category is for the Department B. Okay, now they can draw box plots for each of them, that is side-by-side box plot, so that they can make comparison between them. So the same process will go as we have used for drawing the box plot individually also. And so here you have to draw two box plots, right? You will order these values, you will calculate your Q1, Q2, Q3, then IQR will be there, lower whisker, upper whisker, all these things that you can calculate for both of them, and then you will draw and find if there is any outlier or not, right? Otherwise, if you know about Python, then you can also use the software to get the side-by-side box plot. We will also see it in next lecture. So that is also evident from these box plots also. So this corresponds to Department A, and this is for Department B. In this case, if you see this orange line, this is the median. So you can see that the median salary of Department A is much more than that of Department B, right? Because it is high. Now the spread also is more in case of Department B, right? Because it is varying somewhere around 57 and it is going up till 73, right? So the spread is more, IQR is more. In this case, the spread is less. Also, you can see the shape. Shape is approximately same in both the cases. Here it is a bit, one is less left skewed a bit of it, and then other one is a bit right skewed. You can also see some outliers, because here this observation over here, this is basically giving you an idea that there is someone who is having a very low salary, that is around 30,000, and there is someone who has a very high salary of 95,000. Okay, so here you see this is 98,000. After 76,000, this is an outlier in this case. And here one individual has 30,000 salary. So that is why this is acting as an outlier in this data set. The center, you can compare the spreads. Both departments have similar IQRs, but Department A has a slightly wider IQR. Similarly, you can talk about the shape of the distributions. And you can also see that there are some outliers in the salary distribution. So this is how you compare different side-by-side box plots. Okay. So far we have seen different types of charts or plots that we draw based upon the type of numerical or categorical variable. That is why I emphasize that you should be able to distinguish between these two variables, because last week you saw that the summary measures corresponding to them also differ, and the visualizing tools also differ based upon the type of variable. Okay, so you cannot get confused where to draw a bar chart or a histogram, right? Or where to draw a box plot or a pie chart. So you have to be very clear in your head that, okay, this is the type of the data set that I have, and these are the available charts or plots that I can use. So based upon that only you can go ahead. In the next lecture, we will see how to draw all these plots on the OTT platform data set using Python. Thank you.